Hi there, my name is Mark, and I'm going to try and reduce this monster of an expression. Now, I do notice that in each of the three terms in the numerator, these are powers of base 4, but in the denominator, I have a power of base 2. So my first instinct here is to express each of those powers in the numerator as a power of base 2. Essentially, I'm changing all of those 4s to a 2 to the power of 2. Now that works out really nicely in the numerator, but in the denominator, I have a 2 to the power of x, and it would be really nice to match those 2 to the power of 2's in the numerator. And we have the power of a power law, which says I would multiply those exponents, and multiplication is commutative, which means I can change the order of the factors. So now I can express that denominator as 2 raised to the power of 2 to the power of x. And this is super fantastic because now I can see that I can start creating some like terms in the numerator that match the term in the denominator. And that is 2 to the power of 2x using this power of a power law. Now, that second term is going to be a little bit of a problem, but I think we'll be able to deal with it. So using the power of a power law in that first term, we get 2 to the power of 2x, multiplying those exponents. That second term, again, I'm going to need to make use of the commutative law to change the order of the factors in that product. So that's going to give me my 2 to the power of 2x, but that is now going to be raised to the power of 2. Now that last term is a bit of a problem because right now, I cannot get a factor of 2 to the 2x out of it. So I'm just going to leave it alone for the time being. And the denominator, well, again, that power of a power law gives us 2 to the power of 2x. Now, I'm very confident now that there must be a factor of 2 to the power of 2x in that last term. So now we're going to go ahead and try to find it. And we're going to do so using the product of common base powers law. Now I'm just going to go ahead and write out those first two terms, and now let's express that last term as the product where the first factor is 2 to the power of 2 raised to the power of 2. And I'm going to multiply that by the second factor, which is going to be 2 to the power of 2 raised to the power of x. And that's just that product of common base powers. That common base is 2 to the power of 2. And now we can just go ahead and write in that exponent of 2 to the power of 2x. And look out, we now have a common factor of 2 to the 2x for each term in the numerator that matches that factor of 2 to the 2x in the denominator. Now that last factor in the third term there, that actually is 2 to the power of 2x after using a power of a power law. And in fact, that's probably a good indication to slow it down a little bit and just highlight each factor of 2 to the 2x in blue. And maybe we could also go ahead and evaluate that 2 to the power of 2, which is 4 to the power of 2, which is 16. And then we have our last factor there in the third term, which is 2 to the power of 2x, highlighted in blue. And of course, we'll go ahead and highlight that factor of 2 to the 2x in the denominator in blue as well. Now I'm going to go ahead and just highlight those addition signs because we're now going to make use of the distributive law to factor out that common factor of 2 to the 2x in the numerator. So I'm now going to ask myself 2 to the power of 2x multiplied by which factor will give me the product 2 to the 2x? Well, that is just the factor of 1. Next, I will move into the next term here. 2 to the 2x multiplied by which factor will give me the product 2 to the power of 2x squared? Well, that is just going to be 2 to the power of 2x. And lastly, 2 to the power of 2x multiplied by 16 will give me the product 16 2 to the power of 2x. And we're going to divide that by 2 to the power of 2x. And this is the moment we've been waiting for to get that common factor in both the numerator and the denominator, in this case 2 to the power of 2x, which now cancel to factors of 1. Now I can focus in on the remaining part of our expression here, using the commutative law of addition to collect those like terms, and that will give us 1 plus 16 plus 2 to the power of 2x. And then we can go ahead and evaluate 1 plus 16, those like terms, to 17 plus 2 to the power of 2x, which, I mean, you could express as 4 to the power of x if you wanted to. But I'm going to leave it as such. And my name is Mark. Thank you for watching.